Thanks everyone for coming. I'm going to be talking about building reusable components here at DoorDash. Like Gustavo said, I'm Laura. I'm on the new verticals retail team here at DoorDash. Closer? Okay, thank you. Yeah, so to start, I want to take you back to a distant time. The year is 2022. And in fact, our journey begins far before that. But since we only have limited time, we'll start there. This is the DoorDash homepage, which hopefully you're all familiar with. You can see it's pretty restaurant focused. We have carousels of stores, and a lot of our app looks pretty similar to this, where we have either a list of stores or carousels of stores. So a couple years ago, we created this server-driven UI framework, which we call Lego, which allowed us to iterate on these screens more quickly. And the basis of this Lego framework was that all these components had a common set of response models. So this is what a Lego response model looks like. It might be hard to see, but I'll voice over it. So we have the ID and the component, which just helps us uniquely identify what component we're rendering. We have a text field, which allows us to render the text on the component. We have some images, which could show, we have multiple images, like the main image and some accessory images. And then we have some information about the layout and style. A component might have some children. In the case of a carousel, those are all the cards inside of the component. And then we have this custom field. And we kind of had an inkling that not everything might fit quite nicely into these predefined fields. So we created this custom field, which under the hood was really just a dictionary of string to any. And this allowed us to be flexible so that we could grow to any new features that we needed down the line. And then the last thing you'll see there is logging, which is just used for analytics. So going back to our home screen example, we have the carousel. So the carousel is a Lego model. And then within this carousel, we have some children, which are each of the store cards, like I mentioned. Sorry. And each of the store cards has two images. We have the main image, and then we actually have the little Dash Pass logo, which is an accessory image. And then our component can have some text, like the store name, the delivery time, information about the delivery fee. And then the last thing is this badges component. So this badges component wasn't something that was around when we first created this Lego response model, but that's okay. That's why we have custom. So we just ended up putting it in there. But by the end of 2022, DoorDash was delivering much more than just your lunchtime burrito. We really wanted to bring everything in your neighborhood to your doorstep. So that meant things like retail or grocery items. So here we have this carton of milk, and this looks like it'll fit pretty nicely into our Lego structure. We have an image, some text. We have this stepper, which is what allows you to add the item to your cart or increment or decrement the quantity. And this can be a child component to our Lego, but it needs a lot of metadata to perform its action. So when you add an item, we support weighted items. So we need information about how much it's an increment by. It might not be whole numbers, could be fractional numbers. We need information about the store ID, the item ID, and a whole lot of other things. So all in all, this ended up being about 20 properties. And again, since our Lego model didn't have a great place to put these things in, we ended up just putting them into custom, which was just, again, a dictionary of string to any. And our retail item card use cases continued to grow and grow. So we wanted to show, again, we show weighted items, so we wanted to show how much an item costs per pound. We also wanted to nudge consumers to link their loyalty accounts, so we wanted to show them how much an item would cost if they linked to the store loyalties program. We wanted to give consumers also information about how much inventory was available for a specific item, the ability to show complex deals, and also the sponsor text at the bottom, which we legally have to display. And then we also had this out of stock configuration, which shows the item card grayed out, and then you're able to, instead of adding the item to your cart, you can view similar items to the item that is currently out of stock. And all in all, we were continuing to add more and more things to this custom object. And these were just 4 of the configurations that we had. We had many, many more, so many more that I could not fit them all on this slide. And in addition to just the sheer number of configurations that we had, we didn't have anywhere that these were documented. So we didn't have a single Figma. Each team was creating their new features. So for example, our inventory badges are owned by the inventory team. The grocery team might be the ones that are most interested in weighted items. And each team was just going into Figma, going file, create new file, create new Figma, and then adding their metadata without really knowing what already existed. And then to make matters worse, we were actually showing the same component on 15 different surfaces. These are just 3 of them. And you might think, what's the big deal? These are all probably Lego, so sure, it's a mess, but at least you have one mess. Well, not quite. We had a couple pages, like our in-store search page, which were created before Lego was around, and we just never prioritized migrating it. So we actually had 2 separate models and 2 separate views that we were supporting. And each time that we needed to add new metadata, we had to do it in 2 separate spots. To add to that, we also wanted to show the same metadata in slightly different layouts. So on the left is our buy it again screen, which shows more of like a list configuration. And then on the right, we have our search autocomplete, which also shows as a list, but a slightly different configuration as buy it again. And same issue here, buy it again was in Lego, search autocomplete was not Lego. So we had 2 separate models, 2 separate views, not reusing the same subcomponents, a lot of duplication. So if at this point you're feeling a little bit like this, then we're really right on track to how we were feeling at the end of 2022. So just to recap what we had and some of the pain points. So first of all, we have this really large untyped dictionary that powers many key features of our views. So we just don't really understand what lives in there. There's not really a source of truth. And then the next thing is we have no shared data model between these views. So we would really like to have one model that we can reuse on different configurations. The next thing is we have multiple views based on the view framework. So our views are really tightly coupled to either our servant-driven UI framework or what surface they're being used on. And then the last thing is we don't have a centralized place for designs. So designs are scattered amongst teams. On the flip side, what we want here is we want to create a strongly typed contract so that we really understand what our component supports. And we realize this is a trade-off, right? The Lego model made it so any component could be supported by this one single contract. And that had its pros, but it also had the big downside of we didn't understand what each component could support. The next thing is we want to create one data model that can be reused for all the different layouts. And then speaking of reuse, we also want to be able to reuse one view across the different view frameworks. And then lastly, we want to have one single source of truth for design that all designers and engineers can reference. And we weren't the only ones feeling these pain points. Around the same time, there was another team that was coming up with this idea called the component catalog. And these were some of the tenets that they had thought out for the component catalog. And at this point, the catalog was really more in like an ideation phase, but they had outlined kind of their vision for it, and this was it. So they wanted to create a source of truth, which was just a centralized library of UI components that could be referenced by designers and engineers. They wanted to have a clear data contract for each of those components. And then the components in this catalog should be made for reuse. So meaning they should have really lightweight dependencies so that it could be reused across surfaces and frameworks with ease. So they should have no knowing of what specific surface they're on. They should be as lightweight as possible. And then just to give a better overview of where we see our component catalog fitting, we wanted to live above Prism, which is our design systems library. So Prism contains things like buttons, typography, very, very basic UI like buttons, things that can be reused across both our consumer app and our Dasher app. The component catalog is a layer above that. So it houses a bit more complex UI, but it still holds a lot of the same principles of Prism, where it should be able to stand alone and not be coupled to any specific part of the app. And then we have our server-driven UI frameworks above that, and then our app-specific code. So just to clarify, the component catalog can leverage anything in Prism, like those typography, colors, things like that, but it cannot know anything about the app-specific code. And so this seemed like it fit our use case pretty nicely. So we decided to be one of the pilot teams to adopt the component catalog. And the first thing we did was to create a strongly typed contract. So instead of our Lego response model, we created this protobuf, and protobuf allowed us to create a clear front-end back-end contract, because this is ultimately what backend uses to serialize this component and render it in JSON. So it really does end up being a source of truth, because this is what ends up being fed to the client. So you can see it's pretty specific for our component. It has an image, it has the information about the price and metadata, it has configuration for the quantity stepper, badges, and then the item data was all that information that we needed to be able to add the item to your cart. We had actions, so what should happen when you tap this component, and then we also still had our logging field, which was used for telemetry. And our Swift model maps pretty one-to-one here, so there's not a ton to voiceover here, but the one thing I will say is you'll notice that these are all either primitive types or other models that live within the component catalog. So again, the key here is this should have no knowledge of where it is in the app. It should have no dependency on any sort of like order cart model or like homepage model or anything like that. We should be able to take out this component and have it really stand on its own. So yeah, now we've talked about the strongly typed contract. Next, let's dive into the single data model for all layouts. So I think Gustavo mentioned we're using Swift UI here, which is really great. It makes creating views super simple and easy to read. So you'll see this, this is the retail item card. And all it really takes in is the model, the size of the image, if the cell needs to have a fixed height, and then you'll see here the stepper and the action. So the first thing I want to voice over is the action. So we decided to use this closure-based approach because, like I said, we don't want it to have any domain-specific knowledge. And by coupling the action to the specific view, then we needed to bring in all sorts of things like, is it on the store page? Is it on the order cart page? Is it on the home page? So instead, this is the approach we took. And this is kind of the approach that we take in our design systems library also, right? Like this is really just view code that should live in this library. The next thing I want to touch on is the stepper. So we ended up deciding to inject the stepper, even though it is a view. The reason for that is, as I hinted at the beginning, it was very, very convoluted and tightly coupled with a lot of other areas in the app. So for the time being, we made our item card generic on the stepper view, and then we're able to inject it in. In the future, migrating the stepper to the component catalog is definitely something we could explore. But for the time being, this was kind of like the best path forward to prove this approach. And then the last thing is the body of the view. Again, you can see it's pretty lightweight. It has all these subcomponents, the image, the price, the title, and then the metadata underneath that. And each of these subviews can be taken apart and rearranged into the different configurations that we saw earlier. So on the right, we have the row configuration. And again, it just uses the same subviews, but we just put them in a horizontal stack within a vertical stack, and then we're able to reuse our existing views really easily. Cool, so now that we've talked about our single data model, let's move to reusability across the different view frameworks. So for our Lego framework, I mentioned we didn't want to handle the action within the component itself. And another reason for that is we had a lot of infrastructure already for action handling within our Lego library and in other places, and we wanted to be able to reuse that existing infrastructure. So you can see here, for the Lego implementation, we created this really lightweight view, which all it does is it calls the retail item card, and then it just injects the action handling along with the stepper. And that's really all this view is responsible for. And it should have, again, no business logic, nothing fancy like that. It should just have the component and then the action that it should take. And then kind of similarly for the non-Lego view, you don't need a wrapper view in this case, but you're just able to use the component directly. And then in the on-click closure, we just delegate the action back to our view model as we were doing before. Awesome. So that covers reusability across different view frameworks. The last thing I'll touch on is the single source of truth for design. And to do that, I want to take you ahead to where we want to be in 2024, and then some things that we want to do even beyond that. The first thing is this central Figma file, and this is something that we currently have and are continuing to build out today. So this file, well, we should have one for each component, and so this shows the item card specifically. But on the left, you'll see all the fields that are not configurable. These are things like typography, font, spacing, things like that, that we don't want each team to do whatever they want. We want some sort of cohesion. And then on the right, we show all the different variations that currently exist today. So now if you're a team that's looking to add new metadata to this card, you don't go File, Create New Figma. You come in here and you add it, and you're able to see how it interacts with whatever exists today. And we'd like to take this one step further. Our design systems library has a web page that they host that basically takes what's in Figma and makes it one step further so that it's really easy for product design, engineering, all functions to really like digest and understand what exists today, what each component supports, and things like that. So in the future, this is something that we'd like to add for the component catalog as well. And yeah, that's a bit of an overview of our journey on how we were building reusable components here at DoorDash. Happy to take any questions. Yes. Oh, oh, you can come up here if you want. I'll share with you. Or I can repeat your question too. Yeah, you're already up here.
We're so deep. We're so deep. What was the migration process like when you were going from the Lego approach to this new approach? That's it.
It was long. We started the migration probably at the end of 2022, and then we kind of broke up the different surfaces. We tried to group them together. So for example, we did everything that's within the store page at once as one milestone, and then did everything that was in the order cart flow as a different milestone. And this overall, I would say, took, probably like 6 to 8 months. So it was a pretty long process. But now we are really seeing the benefits of it because we're able to add metadata in like a week's time, and it shows up on 15 different services. Yes. The question was, do we support accessibility? Yes, we do. We add accessibility identifiers within the component itself so that anytime you use the component, it should kind of come out of the box. Yes. Yeah, that's a good question. Yeah, thank you. The question was, how do we deal with versioning if different versions of the app may not support the component? So this one's a tricky one. We have a pretty good experimentation framework here at DoorDash, and when you add a new feature flag, you're able to specify a minimum app version. So when we rolled out this new feature, it was behind a feature flag, and then we said, only users with this minimum app version or greater can use this new code path. And then we kind of monitor the app usage and then determine when we can deprecate the old path. Yes. Yeah. The question was, have we seen any performance increase, as in better or worse, or either way? I wouldn't say necessarily. I think it's been pretty similar. The old view was in SwiftUI, the new view is in SwiftUI. It uses kind of similar components, so there hasn't been a ton of performance benefits in terms of like scroll performance, but I would say like developer velocity and ease of use is definitely a lot better. Yes. Yeah, great question. The question was about testing and how we did that in the process. So we added snapshot tests for all of the different view configurations, or as many as we could. And then as you're adding new features, we also encourage folks to add snapshot tests. Since this is purely a view layer library, snapshot tests are kind of like the way to go here. Yeah. Yes. The question was, do we have any layout abstractions, or if the layout is hard-coded into the component? I would say the layout is relatively hard-coded. I kind of, like I mentioned in, it's pretty one-to-one with what's in this Figma. So in the Figma, it kind of shows what is configurable and what is not. So things like the spacing from the side, or like, vertical spacing, those kinds of things are not to be configured by outside teams. So we keep those static and hard-coded within the component. Yes. Yeah, that's a good question. The question was, is the Figma enough, or should we have some sort of like in-app cut custom catalog that maybe you could play around with? That's definitely something we could explore in the future. We're kind of in the early phases of this, but I think, yeah, having like a place where you could see all the components in our debug menu or something would be really great. I think I touched on, we want to have like a web page library that you can kind of play with them, but I think having something in an app would be something we can explore, yeah. Yes. We don't do a ton around that. I think our app, I want to say, does not support dynamic size, but it's aside from kind of what's the default there. So there's not a ton that we do special there. We still limit kind of the number of lines for the component, so things would just get truncated, unfortunately. Yeah. Oh. Sorry, there's a different tab. Yes. Okay. Is the render done in UIKit, SwiftUI, or web? Most of our consumer app is SwiftUI, so everything that we're building today is in SwiftUI. This was in SwiftUI, and if you join DoorDash, you can write SwiftUI. And then the next question was, are parts of the structure broken into Swift packages? Yes, so the component catalog is its own Swift package, and at the beginning, we kind of toyed with the idea of whether it should be kind of its own separate repo, which is what our design systems library does. It's its own separate repo that we pull in. But we ended up deciding that people were probably going to be iterating on these components a lot more quickly, so it made sense to have them be a package, but within the app. I think that was it from questions in the chat. Any more questions? Oh, yes. Yeah, definitely. We were kind of like the pilot team, but there's other teams that are actively migrating their components as well. Cool. I think that's, oh, one more. Yes. Yeah, the question was this iOS only, or was it across all platforms? We had a developer from each platform, so the migration was also done on Android and web.
Thank you, Paul, for organizing this. I know that you're super busy. Thank you, DoorDash, for hosting. This is a pretty awesome office. So, yeah, I'm here to talk about Swift package managers. As software developers, we often face the challenge of like old stuff getting deprecated, new stuff getting added, and such is the case with SPM. So I'm going to share with you the journey that we migrated from Cocoapods to SPM and the benefits it brings, and also why we actually start doing it. The challenges we have during the migration. So we'll share some resolutions, the hurdles we encountered, integrations with other build tools. That's basically like Bazel. If you guys use Bazels, how do we integrate that with Bazel or Xcode Gen or Twist? All those other build tools, how does SPM works with those build tools? All right. So the first question I have is, I love Xcode, but how many of you guys actually use other text editors? Like Visual Studio Code, Vim, Emacs? All right, so one of the amazing benefits when using SPM is Language Server Protocol, LSP. LSP gives you the autocomplete, go to definitions, linter errors. This unlocks other text editors because this is very crucial for Swift to be adopted in different platforms, in different types of applications, right? So that's very nice. And the second thing I will say is the bash scripts or fastline scripts, a Ruby script. So SPM offers build tools plugins that allow developer to write scripts in Swift. So you can execute them before or after the build phase. SPM also offers command plugins, which allow developers to add custom menu actions. And this is really helpful if you want to do like formatting your code or doing some sort of generate some documentation for your code or anything you want to. The next thing I want to say is the seamless integration with Xcode. Actually, can I click on this? Yeah, there we go. Seamless integration with Xcode. So I hate context switching, right? You go to terminal, you do py install, but you don't have to do that anymore because with Xcode and SPM, you can simply click the package.swift. The Xcode will open, will fetch all the dependencies, and also give you a really nice view of all the dependencies you're fetching, and also will generate a test suite on the test panel, so you can have a really clear, nice, organized view of your project. And you don't have those pods.xcode project anymore, so that's also very nice. Swift macros. So if you're using Cocoapods and if you want to use Swift macros, you can't do that because Swift macros are only supported through SPM. Although there are different ways you can work around it to wrap the binary with the Cocoapods, but I will talk about that later. I think the reason number 2 is dependency management. It offers a little bit better user experience in terms of dependency management. So in Cocopod, if you have a module, if you want to do like a sub module, you have to do something called subspec, right? The problem with the subspec is that when the symboling module is trying to import that subspec, you don't have to specify import statements. So that really is not truly a submodule per se. But then SPM actually offers that. So SPM offers different targets, right? You have binary targets, you have a different test targets, you can have executable targets. And then when you're importing targets as dependencies, you will actually import them. The next thing is pretty interesting. I don't know if you guys seen this before, is the package accessor. So if you have a package and you have different targets or modules, and if you want to expose only certain APIs within the same package, you can use package accessor. It's very similar to SPI, System Programming Interface. Next thing is the semantic versioning. So SPM offers other kind of more intuitive ways to manage your versioning. It has like up to next major, up to next minor, branch exact, or even revision, like actual commit hash, if you want to check out certain commit hash where your app is crashing. Reason number 3 is modularity. Which I think is the most important reason to consider using SPM. Because as your team grows, one of the things you will face is managing your dependencies. So how do you make sure the one team's feature doesn't impact other teams' features, right? Unwanted side effects. So that's when you actually have a modularized codebase. So, someone might say, I can use Bazel, I can use Xcode Gen. Why do I have to use SPM? I would argue that SPM offers more intuitive like user interface and more like, first party being the first party supporting tool. It gives you more out of the box than other things that like Cocoapods or Bazel or Xcode Gen. So this is I guess this is a kind of like a setup that you can see. You have a like app that will be your main app, and then you might have a test host for testing your application. Then you have different sub modules or targets like design system, network, models, etc., etc. And I will say the bonus part about this is that once you become a library author, you're forced to think more about the dependency you consume from third party. Also, you start to think about how do I increase the test coverage for my library? Because now your customers actually are other developers, right? So now you become more familiar with it. Oh, documentation, should I make documentation updated because my developers will use it? Can I providing better debugging tools like error messages, right? So for other developers. So that really makes your code much more clean, right? It's easier to test, easier to extend, and easier to debug. All right, so challenge number 1. So when we're migrating from Cocoapods to SPM, the challenge number 1 is bundle. So SPM bundles things differently than Cocoapods. It apparently actually creates a static variable called module, like accessor for like module to access your resources. So that was the first challenge when we were running the test. All the tests were failing because you can't really get the resources from the bundle. So one way you can do it is to using this if Swift package macro, and then you import your package or you do whatever you want to do for your accessing your module, and then if it's CocoaPod, you can just do my pod. So here's example, right? Before we have bundle for some class, that's off, and then you get the access to the resource. But now you have this module that generated for you. So yeah. Another solution for this problem is that you can actually wrap your resources into a target. And then you don't have to do this. You don't have to worry about module or for some class being there. You can just import the resource for your test modules or test targets. Challenge number 2, no app target. So I don't know how many of you guys use Keychain API from Apple, but if you want to test it using unit test, you have to have a host app because it requires entitlements. So how do we do that? So one way you can do it is to creating a protocol and to mock it, doing dependency injections, and that's easy. Or another option is creating a test host app Xcode project and use that only for testing purposes. I recommend the first approach. The challenge number 3 is library doesn't support SPM. And that's probably the biggest problem because when you are converting one of the core libraries to SPM, but then your consumers somehow don't have the time, don't have the bandwidth to convert to SPM. So now you're kind of stuck. Like, okay, I can't really migrate the whole code base because I'm waiting on this particular pod to be converted to SPM. So what do? There's really three options. One is to add it for them. Like, hey, team, I'm going to add SPM for you. Just being a nice gesture, I guess. Or you can remove it. If the package is or if the library is so outdated, it doesn't support SPM, maybe it's the time to remove it and then doing your own implementations. The third option is using a binary. So what that means is that you can actually creating a binary out of the as XC framework and zip it up and put it into Artifactory. And then other packages or other Cocoapods, when they're consuming it, they can just consume this zip file. Just like Cocoapods also supports that as well. Challenge number 4. This is the last one. Large code base. It takes forever to fetch. If you have a monorepo and the package.swift is at the root of your project, it will take, I don't know, 30 minutes even. Sometimes it's longer to fetch the actual package. So that's a huge problem for us, right? So there's 2 ways you can fix that. One is you, like I said, creating XC framework with a library build file and then put it into the Artifactory or Nexus or somewhere that you can easily download. Even a Git release page is fine too. And the second option is creating a separate repository. It really depends on your organization. Some organization really wants monorepo, so you can't really do the option number 2. So the last point I want to talk about, like integration with other build tools. Xcode Gen is a build tool that can generate Xcode for you, hence the name. It's basically the manifest file it's called project.yaml. It's really easy to use SPM with Xcode Gen. You simply specify, if it's a local package on the left, you basically just specify the path to the package. And when you want to specify the dependency, you specify the package, name of the package, and the product from the package. That's the same thing on the right is the remote package. Bazel. I'm not a Bazel guy, but I know Bazel is very powerful, very, very fast. So you can do something like this, basically having your own build file, right? Swift atomic.bazel. You can do your own build file if you want to. Sometimes it's easier to do that. Or you can use a rule Swift package manager. That's an open sourced rule for us to use. So you can just use that directly. So lastly, I want to talk about integration with Cocoapods. So that's where I was alluding to earlier where you want to you want the downstream consumers to consume your package, but they are not supporting SPM yet. What do you do with that? So kind of like this diagram here, you have this package 1, but how do we let pod 1 to consume package 1, right? So these are the 2 blog posts I got the inspiration from. Shout out to those guys. So the basic premise is that you are building your library, your package with SPM, but then you wrap it into a pod spec. Yeah. So so that's basically how you do it. Feel free to, I will send the slides out later. You can check out these links. They go into much detail how to do it. We actually did it the first one, the Swift macros, because we want to leverage the Swift macros. So we actually did the first blog post. So summary, SPM offers more functionalities than Cocoapods due to its being the first-party tool from Apple. SPM offers more explicit semantic versioning, like up to next major, up to next minor. SPM migration helps developers be more mindful of designing their APIs, particularly about modularization and also dependency management. Bundling is a challenge for sure, but it's more just a grind than a technical challenge. Without app target, testing an app can be difficult. So you do have to think more about how do you open your APIs to for other developer to mock the data to do their unit test. Yeah, so some dependencies are not converted to SPM. So that is the biggest problem. You know, you need to convince them to go to SPM, or maybe do it for them, or maybe just do using a binary. And yeah, SPM integrates well with the Bazel, Xcode, and Cocoa by itself. And that's it. Yeah, questions? Any questions? Maybe you should move somewhere else.
Hey, so per my understanding, SPM only uses static linking. Did you have to deal with any of the problems that the static linking brings, like when you have libraries depending on the third party, but each of them depends on the another library, and because this is statically linked now, you're gonna have compiler errors?
So the question is, SPM only for static linking. Do you have you ever run into any dynamic linking issues, linker issues, right? We haven't. I think it's because we're using Xcode Gen, and behind the hood is kind of linking it for us. And also SPM does support dynamic libraries instead of static or dynamic libraries. So if you specify your target or your product as dynamic, it will be kind of like not embedded. You know, when you're linking to the app target, you have to specify, do you want to link this or embed this into your app target? So yeah.
Hi, what was the timeline for the migration? Have you migrated everything already to SPM, or you're in the middle of the process?
Yeah, we're 90% there. There's like the last challenge was the mono repo. We have a mono repo, and that so we have a lot of other dependencies that haven't converted to SPM yet. So, and we want to keep as a mono repo. So we're like 90% there, and that is like the last stretch. The whole timeline is about, we started this last year, so it's been a while. We're a pretty large organization, a lot of teams, so it's pretty difficult to do it in 6 months, which I think is really fast.
Test. Okay. Can you tell us more about the keychain testing and integration you do? Is it its own package? And like, can you tell us more about the test app setup, like any of those intricacies?
So we don't test keychains with a host app because we don't want to rely on a host app target. We simply create a protocol called, keychains protocol, and creating kind of like a templating pattern where you have a default implementations for these keychains that conforming to these protocols methods, like add keychain, delete keychain item, remove keychain item, whatever. And then we have a default implementation for it, which is the Apple implementation of it. And because it's behind a protocol, in the test target, we inject that into, we create another class called mock keychains that will conform to this keychain protocol. And that mock keychain essentially will handle all the storage and access of the security stuff. We also put it behind an isolated lock or recursive lock, I'm sorry, so that it's threat safe. Yeah, that's it.
Over there.
Okay, quick question. You briefly mentioned Artifactory and the problem with XE frameworks in general. What is, do you folks have a particular solution that you use for hosting XE frameworks? And since you did mention Artifactory, have you tried the Swift package registries that they support?
Yeah, that's a good question. We So like I mentioned, we're like 90% there. The last 10%, that is the question, right? It's like, hey, upper management, do you want us to use Artifactory or do you want us to use package registry, right? So yeah, so that was the answer. That was the question I'm trying to ask the upper management. But yeah, we do use Artifactory. It's good. We store a lot of artifacts there, a lot of binaries there currently from Cocoapods. Yeah.
Question? Oops. All right.
Hi. Does your code base contain any React Native or similar libraries that use Cocoapods as their infrastructure? Because it's imply a lot of other issues. Does your code base contain any React Native or other types of such libraries that use Cocoapods as their infrastructure?
No, we don't use any React Native. And to answer, yes, we have a design system that is its own package or Cocopod. Currently, it's consumed by others through Cocopod. But then this design system wants to leverage Swift macros because, a lot of boilerplate code for Swift UI for sure. So we are basically wrapping the Swift macros with Cocopod. So any other downstream consumers, when they consume this design system module through Cocoapods, they can still use it because Swift macros wrapped.